Hey everyone, so we are going into chapter 9, which is our unit 8 in Schoology, but it's a super quick unit over transformations in a coordinate grid and symmetry. Uh, Literally 2 days, so we'll be testing on Tuesday next week before you go to Thanksgiving, so just be aware of that. Make sure you ask lots of questions as we go through. We did an activity in class today that summarized these notes, so you shouldn't really have to watch the whole video, but we are going to go through everything as well, just in case. So that includes some vocabulary that we may not have touched on in class. So a pre-image of a shape and an image of a shape are really the whole idea of a transformation. So how we move from what's called the pre-image to the image, excuse me. So a pre-image is what you start with, which may feel odd to call it a pre-image, but it's not your goal. Your goal is your image, which is the resulting figure so after a transformation has occurred. Can you talk some about transformations in, like, I think it's the 5th grade, you call them like turn, flip, and slide or something like that. And so just taking that idea now and applying it to coordinate geometry. A translation is when a figure is moved from one position to another. So we don't change the shape of the object at all or the direction it's facing. So let me get this down here. Okay, so a transformation that shifts all points of a figure in the same distance in the same direction. So for example, given A at 3, 2, B at -2, 4, and C at 1, -2, you have this triangle right? If we want to translate the given figure 2 units to the right and 3 units down, we're going to take every point in there and go 2 units to the right and then go 3 units down. And then we label this what's called B prime. So every time we move it, we add an apostrophe. So that would be B prime. Again, 2 units to the right, 3 units down. We end up with A prime. 2 units to the right, 3 units down, and we have C prime. Okay. So we can connect that new triangle and hopefully use a new color. See clearly that this triangle hasn't changed anything but where it's located in the graph. It's going the wrong direction here. It's going to be like taking a sticker off of the sticker sheet and slapping it onto a piece of paper. And so we've translated it. Now we list our new coordinates. So A prime is located at, if you count here, 3, 4, 5, -1. B prime is at 0, 1. And C prime is located at 1, -5. And the moment you realize where you messed all of that up because you plotted C wrong to begin with, I plotted -1, -2. And the easiest way to fix this so you don't have to regraph the whole thing, I'm just going to change your example. I apologize for that. Okay. Okay. That's really all it changed. I plotted the wrong point. So these are good. But again, referring back to class, if you weren't in there, you wouldn't have done this, but we can look at the relationship between our primes and our original coordinates. Anytime we move left, right, we're shifting our x's. And so for what's called transformation notation, our original x, y coordinates shifted all by the same amount every single time. Our x values all went right to every single one of them. All right, so we're taking our x value and we're adding 2. And so you can see right here, a was at 3. Now we get a prime if we add 2. Okay, so that's just one example. So you can look and then see, okay, this a started at 2. How do we get to 1? Well, we subtracted 3. And so our y value is just less 3. And that's because we're moving down 3. So we're moving -3. All right. So transformation, you're not altering the shape at all. You're just moving it left, right, or up, down. So left, right is the x value. Up, down is your y value. What is that shift each direction? And that just goes here. Okay. All right, so that being said, you don't have to graph it then every single time. You can get to your prime by performing those operations. So if I have a point at 3, -5, then I'm going to take my x value, and you don't have to necessarily write this, but I'm going to add what I'm moving left, right, and I'm going to take my y value, and I'm going to add what I'm moving up, down. Okay, so a translation of 2 down, well, that's a -2 for my y. All right, I don't like it when they flip that. And 5 units. Let me see if this is a... Nope, we're good. So 5 units up is again a +5, but it's affecting our y. So we're adding 5 to y. So we're both taking 2 away and then adding 5 from our y. So this is x, this is y. We didn't go any left, right. Which means that in P prime, that x value gets to stay the same. Okay. But our y, we need to take away 2, and then we need to add 5. So that's -7 plus 5 is -2. And that is our P prime. You can work the other way as well. So if I know that A is at -3 and -8, and A prime is at 3, -9, how did I move from here to here? Okay, so you look at the distance between -3 and 3 on a number line. So you think about your x-axis and your number line. We're at -3. How far did we go to get to 3? So you can take -3 minus 3, if you don't just know how to do that in your head, and then take the absolute value of that, and that gives you 6. And so the transformation will be x plus 6 for the x value. And then we do the same, we repeat that same process with our y's. How far from -8 to -9? Well, we're just going down 1. So we're subtracting 1 from our current y's. Okay. Hopefully you're listening to this and not just watching it. Otherwise, you're probably a bit lost. All right, so describe the transformation notation. we just want to shift. All right, so like up here, the shift is to the right, 6, down, 1. That's the description of our transformation, which I guess it asked me to do. Here, same thing. This is in notation form, so we see from here, we move from X to X. So we don't move left, right at all. We don't need to describe anything there. Our Y's, though, do shift by 2, and it's positive 2. So positive 2. Y axis goes up, down. So we're going up. So this shifts up 2. And as we're getting into more vocab, I guess we really should be a little more specific here. So backing up just a second, it's a right 6, down 1 translation. Or it translates right 6 and down 1. Here, I really should, instead of shift, say translate. So we're using that vocabulary. Okay. So then we go into reflections, which is again a rigid transformation, meaning that we're not going to change the size of our shape. So when we reflect something, it's a mirror image. If you think about your reflection in the mirror, unless it's one of those crazy wacky mirrors, it doesn't change your shape. Okay, so a transformation that plots each point the same distance from the reflection line as its pre-image. So you'll have different reflection lines, again, as you saw in class today, if you were in there, that you're flipping over. And that's essentially if you fold your paper along that line and then trace your shape, that's what it would look like. So in grade school, you call it a flip. Here, we're going to refer to it as a reflection. Okay. So because we're dealing with coordinate geometry for right now, we're going to reflect over x-axis, y-axis, the y equals x line, which if y equals x, that's this line that runs right here. And then the y equals negative x line, which is the line that goes right here. So 0 y-intercept, oops. 1 slope, with something like that, only straight. I apparently can't draw a straight line today. So again, just reiterating the rules we got in class today, so you'll just have to trust me on this. Each of these has a rule as to what happens. When we reflect a point across the x-axis, so that's like taking here to here, all right? The only thing that's changing value, you can see it still forms this vertical line, is that y value. And so x stays the same and y just changes coordinates. And if you think about your coordinates in geometry, you have positive, positive, right? Negative, positive, negative, negative, and positive, negative. And so we're just switching that y value out. If we reflect over the y-axis, it does the opposite. Our x is going to switch. All right, we're going from here to here. And our y is going to stay the same. If we're reflecting over this line, it's a little bit different because you can kind of see we could still potentially be in the same coordinate. So that doesn't necessarily mean that any signs are going to change. Now they could, but they probably may not. But what happens, it's kind of cool, is that the x and the y will trade places. So whatever was x before is now your y. And then last, y and x trade places, but now we have a negative aspect to it. So negative y and negative x. So knowing those rules makes your reflection not as complex. So like when I have 0, 3 for my A, negative 2, 2 for my B, and let's plot the right C this time, 1, 2, for my C. So I have this little triangle here. Okay. Then I could, without even graphing, without even reflecting it, I could list my coordinates. Okay, so I want to go over the line y equals negative x. That's this imaginary line right here. Okay. I know that, well, this one's on the line, it's going to stay, but everything else is going to flip exactly the same distance from that line onto the other side. So this line here. Okay. So for example, if I have to go a half, a diagonal, and a full, then on this side I would go a half and a full. I know that A prime is going to be right here. But another way to know that is to look up here at your rule. If my A is at 0, 3, then A prime is going to switch these around and make them negative. So I'm going to go to negative 3. 0 doesn't become negative 0. And you can see right there is where I put A prime. Okay, so B prime, if B starts at negative 2, 2, again, we're switching and then making them negative. Well, they're already opposite signs, so when we switch them and then make them negative, look what happens. This 2 goes here and then becomes a negative 2. This 2 goes here and then becomes a positive 2. It's the exact same point, and B is on the line, so that makes sense. All right. C started out at 1, 2. All right. It should go to C prime. The 2 and the 1 switch places, and then they switch signs. So I should be at negative 2, negative 1. This should be my C prime. All right, well look, I've got 1.5 diagonals. There's a half and a 1 diagonal on the other side, so that makes sense. So I connect these, and that is now reflected. If I fold on this line, it will lay on top of that one. Okay. So transformation notation, what is happening every single time you're flipping across that line? Well, xy is becoming negative y, negative x. Okay, so again, you don't have to use a graph every single time if you know the rules. So if A is at 3, negative 5, for example, and we're reflecting over the x-axis, well, again, reminding you, this is the x-axis. If I'm moving from here to here, for example, then the only thing that's changing is my y value. I'm moving up and down. So y changes from a positive to a negative, or in this case, from a negative to a positive. So only the y value should change. So A prime, this stays the same. This changes signs. All right, you can reflect over any line, and you can do more than one reflection at a time. You can do more than one any transformation at a time. And so if B is at negative 3, 4, and we're reflecting over the line y equals 2, well, this is the line y equals 2, right here. It's a horizontal line. So I need to flip over that, which means I'm moving the same distance over here. So this is B prime. So B was at negative 3, 4. Moved to B prime, which is at negative 3, 0. But then it says reflect that point over the line y equals x. Well, the line y equals x is right here. So I need to flip it over now this side. So again, I kind of just count. Here's 1.5, so I go a half and a 1. This point right here is then what we will call B double prime. All right, so this moves into B double prime, which is going to follow your rule of flipping over y to x, which remember just means we're flipping these around. So we have 0, -3, which is indeed where I plot that point and where it should be. Okay, so you go ahead and try these on your own. We'll go over them in class tomorrow, but I'm going to move on to dilation. These notes are going to be extra long. Like I said, we only have 2 lessons. Okay. Typically I do rigid transformations first, so this is a little bit out of order from what I should have had you do, but another transformation is dilation, one we've already worked somewhat with. So making things bigger, smaller, stretching them, but still keeping that shape, so a similar figure proportionally. But now looking at those more in a coordinate grid than we did before. So if A is at 10, 2, B is at -4, 8, and C is at 2, -4. We can dilate that figure through the origin, which just means that we don't need to worry about where the center point is. This is our kind of our center. And so our scale factor can just be treated like normal. Well, scale factor, just like with similar figures, is something you're multiplying everything by. So if B is located at -4, 8, we're going to half both of those. So we're going to go to -2, 4. And that'll be B prime. 10, or A will go to 5, 1. And C will go to 1, -2. And so we now have a shape that is half, oh my goodness, of the other one. So they're similar figures, and we've now dilated it by half. So I was talking about the coordinates as I was listing them, but A is at 10, 2. When you're doing scale factor transformations, so if your scale factor is K, in this case K is 1/2, then your transformation goes from XY to whatever K times X and K times Y is. So again, for this particular one, we're just halving them. So like if B is at -4, 8, B prime goes to -2, 4, because K equals 1/2. C is at 2, -4, so C prime is at 1, -2. And sorry about this here. A, B, C. Transformation notation for this one, we're going from XY to 1/2 X and 1/2 Y. All right. So again, X, Y, scale factor of 5, so 5 times X, 5 times Y. So if P is at 3, -5 as your XY, you're just going to multiply each of those by 5. So 15, negative 25. Not more complicated than that. Scale factor is probably one of the easier ones, especially since you've already done it before. So if describing the dilation, just look at what's happening from A to A prime. So if we have A is at negative 3, negative 8, and that's mapping onto A prime at negative 6, negative 16. Remember that those ratios have to be the same. And so what are we multiplying by that to get that? What are we multiplying by that to get that? So negative 6 divided by negative 3 is 2, and negative 16 divided by negative 8 is also 2. So it is a dilation with a scale factor of 2. Describe the transformation notations. Please go ahead and try on your own. Okay, what is happening there? Also note that you could write this as x over 5, y over 5, and that would be the same thing. All right, and then the last transformation is back to a rigid transformation, meaning we're going to keep that same size again, and that is rotation or turn, as you probably would have learned it before. So we're going to rotate a figure a certain number of degrees about a point, and that point will be specified, and the degrees will be specified, and the direction will also be specified as far as clockwise and counterclockwise. Counterclockwise keep in mind our coordinates are 1, 2, 3, and 4. So counterclockwise goes this way. So you're going to have a positive angle. Right, because you're going in the order that our coordinates go. Clockwise is a negative angle. Or a negative degree. Because you're going this way. So you're going against what this says to do. So when it says rotate 90 or negative 270, 90 in the positive direction, 270 in the negative direction, end up in the same spot. Okay, about that origin, if we're spinning around the origin. There are some similarities with rotations and reflections as far as this notation goes. This one we have negative x. Sorry, I was one ahead of myself. We have negative y, x. Rotating 180 or negative 180 is the same effect. It's half of a circle. And so we flip the signs on both the x and the y to get that effect. 270 or negative 90. We have y negative x. And this remembers what's happening to your points or a full circle. Nothing will happen. That will stay the same. And a full circle is a full circle, no matter which way you're going. Okay, so again, using these to create your new points is the goal of that. Rotation can be a little bit harder by ear. This says to rotate at 90 degrees about the origin, so we're going 90 degrees this direction. So everything in this coordinate will move here, everything here will move there, and so on and so forth. So it's almost easier to use your notations. So x, y becomes, actually I'm going to do this at C. I'm going to work backwards here. X, y goes to negative y, x. And so if we have a at 0, 3, a prime will flip that sign and switch places. B is at negative 2, 2. So B prime, we change the y to negative and switch places. C is at 1, 2. Again, we flip the y sign and change positions. And so then I can plot those points. So I have negative 3, 0 is a prime. Right, that's rotated 90 degrees from one line to the next. Remember, these are all right angles. Negative 2, negative 2, and negative 2, 1 for my C. That should just move one quadrant. Everything should only move one quadrant. So there's C prime, B prime, and that is my rotation. Okay. And so rotation 270 about the origin. Again, looking at those rules, saying, okay, well, 270, x and y flip places, x changes signs. So x, y goes to negative y, negative x, sorry. And so 3, negative 5 for a goes to a prime at negative 5, negative 3. Or looking at what happens, what is the image point after 180? Go ahead and try this one on your own. And then last, describing the notations. When nothing happens at all, we have rotated 360 degrees or negative 360 degrees. You go ahead and try that one or match that one to its rule. Okay, the rest is all you. We will have some time in class tomorrow and we'll do our second lesson. And again, that is pretty much it for this whole unit. So learning those rules. Have a good night.